Hi, today we will look at statistic 2, Poisson approximation to the binomial distributions. So point 1, a binomial distribution with parameters n and p can be approximated by a Poisson distribution with parameter lambda equals to np if the n is large and p is small. Okay, so the approximation gets better as the n is large and p is small. So how do we know the n is large and the p is small? Okay, a useful rule of thumb is that the n greater than 50 and the np less than 5. All right. How do we get np less than 5? The n must be greater than 50, correct? At the same time, the p has to be small. So example, if the probability given is 0.01 or 0.0035, so these are considered small probability. Okay, so which means when you attempt an exam questions, the random variable can be modeled as a binomial distribution. So means when you read the question, you should be able to identify the independent trials, the constant probability. But then you will see with these conditions where the n is large, which means the n is more than 50. And you will see the p is small, right? Example given before. That means the MP, when you try to do the calculations, you know that the MP is going to be less than 5. Then you can conclude that you can use the approximations, Poisson approximation, to find the probability at the end. So the parameter lambda is equals to NP. All right. So now we have a look of an example. Okay, example 1. A machine is known to produce defective components at random and independently of each other. On average, 0.24% of the time. Okay, when you are given percentage, you are given the probability, right? So in this case, 0.24% is going to be 0.120024. Right? In the productions of 500 components, right, which is all random and independent. So you are given the n as well, 500. So which means we are able to identify a binomial distribution here. Where the x is the number of defective components and 500. Probability 0.024. Okay, state a suitable approximating distributions and calculate the probability that at most 2 components will be defective. Right, this should be defective. All right, so we have a large n, see that? N equals to 500 more than 50, large n. And it's an extremely small probability, so we quickly calculate NP. So what do we get? 1.2. So 1.2 is less than 5. So that is where we get the suitable approximation to be Poisson approximation here. And the lambda, the mean is 1.2. Okay, that is the suitable approximating distribution. So now we are trying to find the probability that number of defective component at most 2. So at most mean less than equals to 2. All right. So which means we have to consider either there is no defective item or 1, or maximum at 2, at most 2. Okay. So remember the formula for Poisson distributions: e to power of negative of the mean, the lambda 1.2. Okay, and then as this is a common term, so we factorize out e to power negative 1.2 aside, and then we take 1 for x equals to 0. Okay, followed by 1.2, right, to power of 1 over 1 factorial, or 1.2 to power of 2 divided by 2 factorial. Right, by using this way, your calculation will be shorter. So let's calculate and find out the probability. So the probability is 0.8794. So 87923 SF. Okay, so that is the answer for these questions. Supposingly, this is a binomial distribution, but what does it want? It wants you to use a suitable approximating distribution to find out the probability. In this case, the Poisson approximations. Okay, let's see some past year questions. This is the question from May-June 2013, variant 7.2, question 1. It's known that 1.2%, see, a very small percentage, means very small probability, of rods made by a certain machine are bent. The random variable x denotes the number of bent rods in a random sample of 400 rods. So part 1 state the distributions of x. So can you see? The distribution that we have here supposed to be a binomial distribution. So you have to say that the x follows binomial distributions and then give the parameters where the n is 400 rods and the probability is 0.12. Okay, that is the probability. With such a large n and the small p, part 2 state with a reason a suitable approximate distribution for x. So to find part 2, what are the reasons we have? N equals to 400, so larger than 50. At the same time, quickly find out the MP. 400 times 0.012, 4.8, and 4.8 less than 5. So you just state either one of these two reasons here, 1 or 2, either one with a reason, then you can conclude that the suitable approximate distribution for x is Poisson. And then the parameter 4.8. All right, that is part 2. Okay, now use your approximate distribution, means we are going to use the Poisson approximate distributions to find the probability that the sample will include more than 2 bent rods. So now the x is still looking at the number of bent rods, and this time is more than 2. Okay, as we know, for Poisson distributions, we will not be able to calculate the probability that x greater than something, right? So what do? We will take 1 minus probability that x less than equals to 2. That means we will try to find the probability where the x less than equals to 2 means we have to look for x is 0, 1, and 2. Okay, so e to power of negative, the mean 4.8. Okay, so when x is 0, so there's a 1, followed by 4.8, and then followed by 4.8 square divided by 2 factorial. Okay, right? By now you should be familiar with Poisson distributions, right? And the formula will be given in MF19 formula booklet, and use it. So now we try to calculate the probability. So we get 1 minus 0.1425. Hence, the probability 0.857 round off to 3SF. All right. Okay, now we continue with another questions. Okay, question 2. This is a question from October-November 2015, variant 7.1, question 5. On average, 1 in 2005 adults has a certain medical conditions. So whenever you have this sentence given to you, is telling you a constant probability. So which is 1 over 2005. Okay, now part 1, use a suitable approximations to find the probability that in a random sample of 4,000 people, so n is 4,000, you have constant probability, independent trials. So we are looking at binomial distributions, right? But can you see that question is asking you to get a suitable approximations, and with such a large n and small p, then you know we are going to use Poisson approximation, where the mean, the lambda, will be np, so 4,000 times 1 divided by 2005, 1.6, all right? And you know 1.6 is less than 5, so it satisfied the condition, is a suitable approximation here. So to answer the part 1, probability that more than 3 have these conditions. So we're looking at probability that the number of the adults has these medical conditions more than 3. So similar, we have to take 1 minus that the x less than equals to 3. All right, so 1 minus e to power of negative, refer to the formula, 1.6. So when the x is less than equals to 3, when it's 0, then you 1. Then 1.6. 1.6 square over 2 factorial. Right, that's when x is 2. Now x is 3. 1.6 cubed over 3 factorial. Okay, then we press calculator to get the probability. So we are getting the value to be 1 minus 0.9212. Right? Then finally, the probability is quite small, 0.0788. Okay, round off to 3SF. So that is the probability for part 1 using Poisson approximations. Okay, now we look at part 2. In a random sample of n people, where n is large, the probability that none has the condition is less than 0.05. Find the smallest possible value of n. Okay. So what we want to do is, it's supposed to be binomial where n is unknown and the probability remains constant. And since the question is telling you the n is large, then we are using the Poisson approximations. So that mean is NP. All right. And then information given, probability that none has the conditions. Means we are finding the probability that x equals to 0 is less than 0.05, less than 0.05. All right, so that is the equations that we need, and then use it to find the smallest possible value of n. Okay, so now we use the Poisson distribution formula, which is e to power of negative of the mean. All right, then times 1. And then less than 0.05. Okay, so in order to solve this inequality, what must we have? We need to bring down the power negative n over 2005, and hence in this case we got to put ln both sides. All right, so by using ln both sides, then you can bring down this, and you know ln e is equals to 1. So ln 0.05. And then what's next? You have to reverse the directions of inequality, because you are in this case you are multiplying the ln 0.05 with negative 2005. All right, so what is the value of n? Let's calculate. Ln 0.05 times negative 2005. So 7489.33. 7489.33. So that is the y. Since the n has to be greater than, right, more than 7489.33, and to get the smallest possible value of n, smallest, hence the n must be equals to 7490. Right? 7489 point something. So it must be an integer and more than this number 7490. Okay, so that will be the calculations for part 2. Right, that is what we discussed for Poisson approximation to binomial distributions. So when you read the questions, a quick summary here. First, it has to be a binomial distribution exam questions, right? N is large. How do I know it's large? N greater than 50. And you have an extremely small probability given. So do a quick calculation, MP less than 5. Then you can continue to use the Poisson approximations to calculate the probability at the end. All right. So that's all for today's lessons. Please subscribe to the channel and like the video. I see you in the next lesson. Bye-bye.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with 1 or 2 past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.